Good evening, everybody. We are Team Virus. My name is Robin. I will be one of your two presenters for today. Lucas is also going to be presenting beside me. Our presentation is broken up into 4 different parts. We have the project background, which I'll start off the project with. We'll move into methodology, research, and data, which we'll switch over to Lucas, and he'll continue into our future plans. And we'll bring it back to me to wrap it up with conclusions and team suggestions. You can follow along our presentation with little icons at the bottom of all the slides. The brain representing our background, the test tube for our methodology, research, and data, the calendar for future plans, and shaking hands for team suggestions representing the team. So our project is based on a newly discovered waste clearance system in the brain called the lymphatic system. And it's responsible for the removal of beta-amyloid plaques in the brain. And the way this works is on the orange cells of the brain, on the end feet are purple aquaporins. Aquaporins are proteins there that control the flow of the fluid throughout the brain. All the little brown particles are the plaque buildup. So plaque buildup happens throughout the day. You're learning, you're going to class, you're interacting with people, and then at the end of the day, your brain's just cluttered. So what happens is when you enter deep sleep, so if your professor's saying, hey, why are you sleeping in class? And you're like, it's good for my brain. Well, it's good, it's clear. So what happens when you're in deep sleep is the aquaporins control the fluid flow, they'll flow out and continue on to take all the plaque out of the brain. But what happens is that if there's a malfunction of the system, research has shown that this could lead to an increased chance of developing Alzheimer's disease. But while we were also researching this, we found that there's actually correlation between herpes simplex virus type 1, or oral herpes, and its infection and the lymphatic system. It's shown that there's a downregulation of the aquaporin proteins, which control the flow of the fluid, but there's not really an explanation for this. So it's showing that there's plaque buildup, but we don't really know why. So we're kind of looking at thinking that maybe there's a structural change in a subprotein on the aquaporin that could cause this change in the fluid. And this kind of goes into our hypothesis, which Lucas will now take over.
Thanks, Robin. As Robin had mentioned before, the previous research has shown that HSP1 causes a downregulated ATP4. However, how this happens, we don't really know. So our hypothesis is based on that. We believe that the M23 isoform tetramer, which is a subprotein of the aquaporin fold, and when it's infected by HSP1, that HSP1 will cause either a reduction in production or change in quaternary structure, which causes the malfunction of ATP4. So that's quite a broad hypothesis. And in order to help us manage it better, we broke it down into 3 aims. Our first aim would basically serve to confirm previous research that's been done. You basically infect cells with HSP1 and then see whether or not ATP4 is downregulated, and by extension, the M23 isoform tetramer. Our second aim is to determine whether or not there is a structural change, or if there's a change in RNA level once they're infected. And then finally, our third aim is dependent on our second aim. If our second aim, and we find that their HSP1 causes a structural change, then we decided to try to use a computer model to model this protein and to better see the effects of HSP1 and to better understand exactly what's going on. So right now, we have already started our research on the first aim, and that takes us to our methodology. We divided this first aim into 4 main components that we are currently doing in lab right now. First is the most crucial, is the cell culturing. We right now have 2 different batches of cells, SVG and Vero. SVG are actual human glial cells or brain cells, and Vero are monkey kidney cells. And the kidney cells also do have ATP4, which is what we're researching with. And so that's our basic maintenance. Basic maintenance every single day. We make sure it's alive. We need it for our control, and then we also need to infect it. And then that takes us to Western blot, RT-qPCR, which is real-time PCR, and immunofluorescence assay, each of which I'll get into detail as they show up. So here we see our Western blot results that we have done in our research already. The top right here, this is basically our control group. Beta-tubulin is a protein that's present in all cells, and we are seeing whether or not HSP1 specifically downregulates all proteins, right? Because then if it downregulates all proteins, we cannot say, oh, well, HSV1 has a specific target in ATP4 or N23. This is something that we need to determine first. Based on these results, these are pretty good. This on the left side shows infection after 19 hours, and on the right side it shows infection after 43 hours. And each specific band shows, the intensity of band shows how much proteins there are. And of course, since they're all present, they're all there. And since the intensity of the band is equal across the board, we can see that this protein is expressed no matter how long it's been infected or no matter the infection rate, which we had for each different band. Down below, we now see the specific results based on aquaportin 4. MOC is not our control group, we're not infected, and then as it goes from left to right, it increases in MOI, which you may have heard before. Basically, it's the rate of infection. As MOI increases, there's more viruses infecting each cell. So, as the intensity, as you go from left to right, you see that the intensity of the band is increasing, which seems to suggest that as we're infecting this cell, there is more production of aquaportin 4. Now, this flies directly in face of what we expected and what we had read in our literature. And of course, this is only our first result, so we will be doing many more to confirm whether or not this is true. But unfortunately, at least based on this Western blot, this seems to be the case. In addition, as time increases, aquaportin 4 production seems to increase as well based on these results. Again, we are not completely sure why, and why this also flies directly in the face of previous research, but we will be doing more tests to determine whether or not this actually is the cause. In addition to kind of back this up, we attempted to do qPCR or real-time PCR on the Western blot data. Unfortunately, we did not get as good results as we did in our previous experiments. Green is our RNA level or infection. As you can expect, since we infected different levels, here's like the first band, second band, and third band of infection rates. And red is the control protein we saw in our previous slide, the beta-tubulin. So they also seem to correlate with the infection levels as well. So again, kind of confirming the Western blot results that HSV1 doesn't really have any particular effect on regular protein infection. Here is a second result where we tried to get another result for real-time PCR for aquaportin 4. Unfortunately, again, it was not the greatest. This time it was, again, very strong expression of RNA level in HSV and also in our control protein data too. Sorry, no, this is a different, but it was basically a control. And our blue, which you finally do see as opposed to the previous one where there's nothing at all, is our aquaportin 4, but unfortunately its levels were not large enough to be detected above this point, which is represented by the green line. So we can't really confirm whether or not it's there. Our Western blot evidence implies it is there, and so we suspect that the reason for this weird faulty data is because there is a problem in the primer, which is a strand of DNA that's supposed to bind to the mRNA that's going to be expressed with the protein of ATP4, but since there's no strong signal, we suspect that that's the problem. And finally, we have reached IFA. This is a method in which we're able to see the results of the infected cells and to see whether or not the cells are infected as much as we claim or assume them to be. And like I said before, as MOI increases, the amount of viruses will increase. So on the right, we have our normal, this is what you would see under a light. And because we infected the cells with a specific type of HSV where we attached a fluorescence with it, we were able to see viruses, which are denoted by the green dots here and here, And as we expected and as we predicted, as MOI increased, you see more and more biases. So all of this research, just to summarize, was based on EAM1, and we are currently trying to see if HSV1 does downregulate ATP4. Unfortunately, results seem to suggest otherwise, but of course, we need to do a lot more research and gather a lot more data before we're confidently able to say that this is the case. And so, this kind of highlights all the different things we need to do. We first need to find a primer that works with our qPCR and get a result for sure where we can see the levels of ATP4 being expressed. And we also need to confirm if this HSV1 has the same effect on both viral cells and HBG cells. So this is our timeline that we have so far. We have already gone through spring and summer of trying to suggest our project. And now we're continuing to do research because we're trying to finish up our AIM-1. By spring of 2017, we're trying to finish our second AIM. And if, depending on the results of this spring, we will try to do and finish our third AIM, leaving us time for our senior year to focus all that time on our thesis development.
So, this was a huge thing for us. One of our biggest challenges was immediately after we became a team. You might notice a little bit of a difference between the people in that photo up there and the people standing up here. That's because since we became a team, people started dropping. We lost half of our team, but you know what? It's still good. This is who we are. We are Team Virus, and we have overcame that. It was very disheartening at first when we were, the smallest team of our cohort. We had not a lot of project enthusiasm, but you know what? We got together, and at the time we were still 8. We sat down and we're like, all right, no one's into this project. Let's change it. Let's revamp it. Let's actually become Team Virus. And so that was really awesome for us, and it definitely was our biggest challenge, but we have grown so close because of that. Now, with that, we still have other issues on the team, as other teams have presented before us. Time, scheduling, and involvement all go hand in hand. Between the 6 of us, you think, oh my gosh, 6 people, that seems so nice to make your schedules known. It's so hard. Between all the activities that we do here, it's ridiculous trying to figure out what times. Oh, we have jobs, we have tutoring, all these other things that we're involved with. It makes it very hard to schedule. And also, we have half of our team applying to med school, so when that time comes, and we want everybody to go through with that, it's definitely going to be a consideration for that. That's going to be taking up a lot of their time. But we do have some tips for you guys. Do not compare your team to other teams. It's very, very tempting, so you want to say, oh, well, like, what are they doing? What are they doing? What's their research? How are they doing? As you saw today, every team has challenges. You might think, oh, this is the dream team, they're the best team out there, but you just got to think about yourselves. You can't give up on your team. You really need to be proud of what you're doing. If we gave up and we all said, all right, we're all just going to drop Gemstone, Team Virus is done, again, we wouldn't be here presenting to you today. You really need to be open to new ideas. I know other teams have said that too. Their project today is not where they started. Again, same goes to us. Don't just shut down ideas because it's not what you started with. It's okay to fail. That is something that we have had to accept a few times in our time as a team. But you know what? You still get through. Trust the process. And then going through to a more academic sense, Gemstone is still a class. You get credit for it, so props to that. You get a little A's in there. But it's still a class. You need to treat it as a 2-credit class. Put in the time, put in the effort, and with that, admit when you're struggling. We put all of our tests into our Google Calendar that everybody has access to, which is great. So that way, it's not a surprise attack like, oh, half of our team has tests this week, and it's like, oh, why didn't you say anything? It's like, you should have checked the Google Calendar. So it's just really great to say that. We understand, and we're all in the same boat. And also, people post pictures of their schedule, like, look at my beautiful schedule, but there's an 8 a.m. meeting that's going to be unavoidable. Guess what? We have yet to have an 8 a.m. meeting so far. Use CourseOff, overlay your schedules. It's great. Yeah, we're going to have 11 a.m. meetings. Isn't that nice? So I got 11 a.m. meetings. But definitely use CourseOff. It is great. So with that, we are looking at the unknown link between herpes virus infection and Alzheimer's disease. We're currently in AIM-1, and the biggest takeaway from this is don't give up on your team and be proud of who your team is. We also have acknowledgments to our mentor, Dr. Zhang, our graduate assistant, Lee Ping, who is essentially our mom for the team. She always makes sure we pack a lunch for lab. Our librarian, Kelsey, and some of our experts who are at our thesis, our project proposal, and then Dr. Skendall, the entire Gemstone staff. We've also received the library award last semester, and we did our launch UMD, which was super successful, raised over $5,000 for our team, which is great. And all the names at the bottom are people who have hit the benchmark to go ahead and get acknowledged on these presentations. Thank you.